Hello, I'm Mensa Augustine. In this lesson, we'll be looking at complex numbers and we'll be looking at the basics. So let's see how we do it. Now, we define the complex number z as z equals x plus yi or iy. Now, if we do this, then we have the ordered pair x, y to be plotted on the complex plane. So here, x is the real part of z and y is the imaginary part of z. Now, what does the I mean? The I means I equals square root of negative 1, which was introduced by Euler, a mathematician. So the I means square root of negative 1 in a very simple way. Now let's look at something. If I put the real part to 0, then I'll have z equals yi. So it means that if the real part of the complex number is 0, then the complex number is purely imaginary. And if I put the imaginary part, that is y equal to 0, this part will be 0, and I'll have z equals x. It means that if the imaginary part of the complex number is 0, then the complex number is purely a real number in a very simple way. Now, let us proceed by writing some integral powers of I. We have I equals square root of negative 1. So I squared will be square root of negative 1 squared. So I squared will be negative 1. Now, what about I power 3? Sorry, I power 3. I power 3 is simply I times I times I. That is, I multiply itself 3 times. And we have I squared times I. By I squared is negative 1 times I. So I power 3 is negative I. If I take I power 4 equals I times I times I times I. That gives I squared times I squared. It's negative 1 times negative 1, which is positive 1. Or we can write I power 4 as I squared power 2. And this one is negative 1 squared, which gives positive 1. So let's put them here. We have I equals square root of negative 1. I squared equals negative 1. I power 3 equals negative I. Then I power 4 equals positive 1. In a very simple way. Now, if we consider 1 divided by I, this is the same as 1 divided by square root of negative 1. And we have to rationalize this. So we take 1 divided by I times I divided by I, which gives I divided by I squared, which is I divided by negative 1, which is equal to negative I. So here, 1 divided by I squared equals negative I. Let's take 1 divided by I cubed in a very simple way. Here, this is the same as 1 divided by I squared times I. And we have 1 divided by negative I, because I cubed is negative I. Now, we put the negative here, 1 divided by I. So let us rationalize this. If we rationalize this one, we are going to get negative I divided by I squared, which gives negative I divided by negative 1, which gives positive I. So here, 1 divided by I squared gives positive I in a very simple way. Let us explore more ideas under this. Now, let's say that I have I to the power 4n. Here, I'm going to get I to the power 4 to the power n, which gives I to the power 4 is positive 1. So I have positive 1 to the power n is 1. What about if I have I to the power 4 n plus 1? This gives I to the power 4n times I. But this one is what we've done here already. It's 1 times I gives I. Now what about if I take I to the power 4n plus 3? This gives I to the power 4n times I power 3, which is equal to, this one gives positive 1 times I power 3. And what is I power 3? Negative I. Okay. If I take I power 4n minus 1, this will give me I power 4n divided by I. But I power 4n is positive 1 divided by I. So we rationalize this. 1 divided by I, we've done it already, is negative 1. So this entire equal, negative I. If we rationalize this, we get negative I. Then let's say I have I power 4n minus 2. This will give me I power 4n divided by I squared. Remember, we are doing this using the laws of exponents. If you have a power m divided by a power n, then you have a power m minus n. So we send this one back here. That is what we are doing here, right? So here, I power 4n is positive 1. And this is I squared. I squared is negative 1. So we put negative 1 here, and this is negative 1 in a very simple way. We can go on and on and on and on and on and on. Let's do, say, I power 4n minus 3. This will give us I power 4n divided by I power 3, which is equal to 1 divided by I power 3. And what is I power 3? Negative I. So we have negative 1 divided by I. I power 3 is negative I. Now let us rationalize this. We multiply here by I and multiply here by I. This will give us negative I divided by I squared, which gives negative I divided by negative 1, which is equal to I, in a very simple way. So this is how we express some powers of I in a very simple way. Now, if we take this, if we consider this one a complex number of the form z equals a1 plus b1i, and that's z1, and z2 equals a2 plus b2i. Now, if I want z1 plus z2, then it means that I have to add the real parts together to get a1 plus a2. Plus, I add the imaginary part together. I have I add, so I bring I out and add b1 plus b2 in a very simple way. Now, what about it if it is multiplication? If it is multiplication, if I have z1, z2, z1 times z2. Okay, let's do addition first. If I have z1 minus z2, then I'll subtract the real parts, a1 minus a2 as the real part, plus I, then b1 minus b2 as the real part. Now, the multiplication z1 times z2 is a1 plus b1 B1I, A2 plus B2I. Now we use the distributive property. So let's see, we have A1 times A2 is A1, A2. A1 times this gives plus A1, B2I, plus this time that gives A2, B1I. Then this time this gives plus B1, B2I squared. But I squared has been done here, that is negative 1. So if we multiply this one by negative 1, here becomes negative. So we group the real parts, that's the one that doesn't contain the I. So we have A1, A2 minus B1, B2 plus I here. We bring I out, and then we write A1, B2 plus A2, B1. And they're very simple here. Remember, I can be here, or we can put the I here. Anyway, it is accepted. So that is how we do with multiplication. Now, what about division? What about division? So if we are dividing, what do we do? Let us divide and see. Let us divide and see. So let me do one example on this before we divide or we add. Let's say that I have Z1 to be 1 plus 2i and Z2 to be 3 plus 5i. Then if I take Z1 plus Z2, what will I get? 1 plus 3 is 4. 2 plus 5 is 7. Then Z1 minus Z2 will be 3 from 1. That is negative 2. That is like this. 1 minus 3 plus I, 2 minus 5. So this gives negative 2 plus I, negative 3. This gives negative 2 minus 3i. In a very simple way. Right? What about the multiplication? Z1, Z2 will be equal to A1, A2 minus B1, B2. So we multiply this together. 1 times 3. So we take 1 times 3 minus 2 times 5. One times 3 minus 2 times 5. And then plus, we come here. A1, B2. A1, B2. A2, B1. 1 times 5. 5. And then 3 times 2. We are getting 6. Then we bring I. So this will give us 1 times 3, 3 minus 10, that is negative 7. And this will give us plus 11i. Now let us verify. We don't need to memorize this formula. We can use the distributive property as we've done it here. So Z1, Z2 is simply 1 plus 2i times 3 plus 5i. 1 times 3 gives 3. 1 times 5 gives plus 5i. 2 times 3 gives plus 6i. Then 2 times 5 gives plus 10. And I times I gives I squared. So this gives I squared is negative 1. So we have 10 times negative 1. That gives negative 10. So this gives 3 plus 11i minus 10. Because I squared is negative 1 times this gives negative 10. So this gives us negative 10 plus this gives negative 7 plus 11i, as we have done here already. Now let us look at the division. We will be doing addition, subtraction of complex numbers into details in the next video, and then we're looking at the division to in the subsequent video. So these are just the basics. Now, if I have Z1 on Z2, that is the complex number Z1 equals X1 plus Y1 I, and Z2 equals X2 plus Y2I. Then Z1 on Z2, where Z2 is not equal to 0. You can look at the Z2 is not equal to 0. It's simply given by X1 plus Y1 I divided by X2 plus Y2I. Now, with regards to this, we have to rationalize. So if we want to rationalize, what we are going to do here is very simple. We take this one and then rationalize. So let us rationalize. We multiply here by x2 minus y2I, and multiply the denominator by x2 minus y2I. Now, what is x2 minus y2I? That is, if you have a complex number z equals x plus yi, then we talk about z bar. Z bar is called the complex conjugate of c. Z bar is the complex conjugate of z. So the complex conjugate of this z is given by x minus yi in a very simple way. So if I have z equals x minus yi, then the conjugate of this one will be z bar equals x minus, I have minus yi here. So this will give me x plus yi in a very simple way as the conjugate. So we use the conjugate of this one here to rationalize. So let's do the rationalization. Now, for the rationalization, we have to multiply what is at the top and then multiply what is here. Now, for the denominator, we have difference of two squares. We have difference of two squares. If you have a squared minus b squared, is a plus b times a minus b. So we can imagine that one here. Very simple. We have x2 plus y2I times x2 minus y2I. So for the denominator, we will use difference of two squares. So that will give us this one squared, x2 squared minus y2I squared. So let's put this one here and expand. x1 times x2 gives x1, x2. x1 times y2 gives negative x1, y2I. Then this times this gives plus x2, y1, I. Then this times this gives minus y1, y2, I squared. Okay, so let's proceed. This one gives me x1, x2. Now, I squared is negative 1 times negative gives positive. So I bring plus y1, y2. That is very simple. Now, what do I do here? It has left with this. I have I here and I here. So I'll write plus I into, I have negative x1, y2, and then positive here. So I have x2, y1 minus x1, y2, all divided by x2 squared. Then here, this will give me y2 squared. And then here I'll have I squared. But I squared is negative 1 times negative gives positive in a very simple way. So we are going to get this one as x1, x2 plus y1, y2 divided by x squared plus y squared plus I into x2 y1 minus x1 y2 all divided by x squared plus y squared. So this is the real part and this is the imaginary part in a very simple way. Thank you for watching. Please like, share, subscribe and leave your comments.